Yep, it's going. Hello, I'm Mark Abney. I'm the Assistant State Soil Scientist, and we was just going to talk to you today about how to describe a soil. And so John Kabrick is helping me, and he's holding the camera. So I'm just going to have him kind of look around here at the landform we're on. We're on a nose slope, down pretty low. We're not too far from the Missouri River, so we're near a lush source. And we have a soil pit here, and so we're going to look at this soil pit and see what the properties are on this soil pit. So follow me into the pit, John. So we have this soil here, and we dig the pit out, and once we get the pit dug, then we start to put in horizons, and you can see horizons in this pit just from what the camera's showing you. This is a surface horizon. This is the next horizon. It's a little bit lighter color, and then it gets a little redder. There's a horizon in there, and then the structure changes. And so when we talk about structure, we're looking at the soil aggregates, and you can see these aggregates are breaking into blocks, subangular blocks. And so we describe them, and the blocks are increasing in size as we go down because the clay is increasing in size. And so you can see in this next horizon down that the structure is increasing. We look at texture, and that's how well the soil will make a ribbon, which tells us how much clay is in the soil. And we figure out how much clay is in the soil, so the clay is increasing as we go with depth. And so we've cut out these soil horizons based upon structure and based upon clay content and based upon colors. And so we're looking at this material coming down here, and we call this A horizon. We called it a BE. So it's part of the B horizon, which this is all B horizon here. And E horizon means eluviated, which means washed out. So material has washed out of this layer into this layer. It's washed out and went down slope, and so clay is moved out of this layer by water movement in the soil. That's why we get this lighter color up here, this E horizon. So we call this a BE because it's kind of mixed with B material. And then we go into a B, and we call this a BT. The little T stands for an argillic. Argillic means that clay has moved into this layer, and it's illuviated, which means moved into. So the clay has moved into this layer, and as water comes and rainfall falls on the soil, it moves clay down into the profile. And then water also moves up in the profile during the summertime with evaporation, and as the trees take water out, and it moves clay up. Clay moves down, clay moves up, and you get an increase in clay in the middle. And we call that a clay bulge, which has a technical name called argillic horizon. This has a good argillic horizon in it. And as we're coming down, we're looking at this material. This material that we're looking at in this part is all loess material. Loess is windblown soil. This material blew from the Missouri River after a dry period, after glaciation, and was deposited on this surface here. This layer here, from this T, this pin, down to this pin, is a different loess deposit. And we know that because it has a different consistency, it has a different structure, and the bulk density is a little higher on this layer. The consistency is a little firmer. You can see this almost when you push on it, it almost pops when it breaks. So it may have some slight cementation, but it is a different layer, a different loess source. And so we put a 2 right here, indicating that this is a different material here than this material. So this is an A, this is a BE, this is a BT1, top of the argillic, a BT2, a BT3, and then this would be a 2 BT4. This material here, you notice that the color increases in brown or red material, red colors. not really red, but more browner material. And it's not as the consistency is not as high as it is in this layer, even though it is pretty heavy. Consistency is pretty firm on this layer. But notice also the black manganese stains in here, and manganese tells us that the water is slowing way down and it's precipitating manganese stains. So you can see these black manganese stains in here where you don't see them up in the material above. And so that tells us that this is a different material, and it's impeding water movement. And so the water's moving down through the soil, but as it hits these lithologic discontinuities, these different materials, it slows down. And so it's slowing down pretty good here because it's dropping out or precipitating the manganese. And the structure is increasing. So we have good prisms showing up in this layer. And then that breaks into smaller blocky structure. And so then we come on down, and this would be a 3 BT5. And then we have this last pin here, which is part of that 3 material. But the structure changes. It's increasing in size. The color's changing. There's more manganese down in here precipitating out. It could even slow water down where there'll be some gray mottles. And I think I see one right there. There's some gray material. So that's reduced iron, and so the water's really slowing down when you get down here, and so it's reducing the iron. It's going so slow. So we have this horizon down here. This is kind of how we describe soils, and if you'll notice, the history of this soil is all locked into this profile. So it kind of tells us how it all developed here, right where we're at. This material down here, this 3 material, is what we call hill slope sediments, which is a colluvial type material. So this material moved down slope, and we're on a pretty steep slope here. We know this material moved down slope because it has chert fragments in it, and the chert fragments have been rounded. The corners have been knocked off, and so it's probably got 5–10% fragments in this layer, in this 3 material. So this is colluvial material with the loess deposit on top of that, with another loess deposit on top of that loess deposit. That kind of sums up this here profile. We'll describe all these roots that you see, the abundance of them, the size of them. We describe all the colors, and we use a color book. We also describe structure and texture, clay, the clay, sand, silt percentages. We describe all them. And the next video that we're going to take is a video on how you would sample this soil to send it to the lab. And so once you get it described, you're ready to start sampling. And so we'll kind of conclude this here description now, and then we'll do the next video, which will talk about sampling.